Welcome back, students, to the part 2 from the chapter Dual Nature of Radiation and Matter. In this section, we are going to study about photoelectric effect. As we had discussed in the previous slide, photoelectric effect refers to the electron emission when light of a particular intensity or frequency falls on a metal surface. Hertz observed the following. In 1887, Heinrich Hertz observed that when light falls on a metal surface, some electrons near the surface absorb enough energy from the incident radiation to overcome the attraction of the positive ions in the material of the surface. After gaining sufficient energy from the incident light, the electrons escape from the surface of the metal into the surrounding space. Later on, Hallwachs and Lennartz conducted a series of experiments and observed the following. They observed that there is a certain minimum frequency known as threshold frequency below which no electrons were emitted in photoelectric emission. The experimental study of photoelectric effect is as shown in the figure. This schematic diagram was used for the study of photoelectric effect. So let us go into detail about the description of this diagram. In this diagram, you can see an evacuated glass tube, two photosensitive plates A and C, which is taken as the anode and the cathode, a quartz window through which light can enter and reach the cathode, the two ends of anode and cathode being connected to the parts of a commutator. A commutator is a device which helps us in reversing the current. The entire setup is being connected to a voltmeter and a microammeter to measure the voltage and the current respectively. To vary the voltage and current, it is connected to a rheostat and a battery. So we have seen a voltmeter is connected across the two plates, which helps us in measuring the potential difference between the plates. And there is a sensitive galvanometer or a microammeter in the circuit, which helps us to measure the photocurrent. The collector plate C emits electrons because of the light which is falling onto it through the quartz window, which are then collected at the plate A. These plates are connected to a battery via the commutator, and if we switch this experiment on, let us see what happens. So you can see a quartz window near the cathode, that is near one of the plates inside the evacuated tube. And this quartz window has two functions. It lets the light in, and it only lets the ultraviolet light in. Hence, by using a quartz window, we can make sure that light of a specific frequency falls on the metal plate inside the evacuated chamber. So, in the beginning, let us have a zero potential between the plates A and C. We open the quartz window and let the light fall onto the cathode and observe the voltmeter and ammeter reading. We can see that both the ammeter and voltmeter will give a non-zero reading for alkali metals, proving the occurrence of photoelectric effect. If we are increasing the voltage across the anode and cathode, we can observe that the amount of photocurrent will be more. Hope you have understood Hertz's observations and Hallward and Lenard's observations, which led to the theory of photoelectric effect. Also, the experimental setup which is used for the study of photoelectric effect might be clear to you by now. Thank you, dear students.